I welcome into today's video a continuation of what we have already studied. More importantly, the previous section. Right, revisit the previous video. Please don't hesitate, more especially for those who are joining us. Please do so. This is just a good link. You can use it to watch all the videos we have had. Previously, we are looking at the section where we are trying to find the equation of a straight line. Right, objectively, what is here? Always, at least, you need to know what we are doing. It's not just a matter of discussing a section on its own. It's mathematics. There must be a logic. A logic of which here is an issue that you need to consider. A Cartesian plane, and the line is drawn within it. For example, this is my Cartesian plane where I have the y and x-axis intersecting at the point we call the origin. Like this one here, this is y-axis, x-axis intersecting at that point of origin, and you have all along, these are just the scale. You have 1, 2, 3, 4, and here 1, 2, 3, 4. On the this other side, they have got negative values. That's the below 0, negative 2, and below 0 on the y-axis. Those are the values of what? Y and negative 2. Right. The start is about the line. I draw a line here connecting 2 points. Say, for example, this point here, A, connecting to point, say, for example, that point, that is point D. When I join the 2 points, I have a straight line segment like this one. Like, so that's the study. We've done a lot about this line, just like an example, and all other lines drawing the Cartesian plane. Right, so I've been looking at several issues about it. A study about the gradient, a study about the equation of a straight line, a study about the distance between 2 points, all those things, and more things you learn about them. Right, so today, what is it that you need to know? Here, we need to discuss issues about lines which can be drawn here. Sometimes you can draw several lines on the Cartesian plane here. Now, there might be a situation whereby some other lines will be defined as parallel, right? So here, you would like to learn something about that. What is it that we need to know? As much as what we have been doing in the previous section, remember, we have been calculating the equations of the straight line to mean to say that every line has got an equation. So here, we are going to specifically discuss on how we can calculate the equation of a line, right, that is parallel to the other one. Right, so thus it is about the parallel lines, but objectively, the target is to work on the equations of lines which are known as parallel. So it's just like one equation, you have it, and the one line, you know its equation. What about the other line, which is parallel to the other? They may be asking you to wake up the equation of that other line. So that's it. Right, so here, it'd be like I have got line maybe 80, with the values of x here, and y, and here value of x and y. Suppose I draw several lines here, and here is another line in respect to the what? X-axis, and I draw another line here, like that one, and I'll draw another line here. Right, we'll be there trying to be asked to show that any 2 pairs of lines are parallel. Right, and then we will also be asked to wake up the equation of those lines, maybe the equation of the line given the equation of the other line. Right, so first, let's discuss here. If we say that lines are parallel, how can we recognize the parallel lines? That's the first thing that we need to know. Once we have known that, then the other section that we're going to discuss about the parallel issues will be just there, be done very easily. Right, so from the normal circumstances, whenever we talk of that 2 lines are parallel, we are there to just define that in a simple way, that lines are parallel if they are heading toward the same direction. That's the primary school definition. Meaning that the distance between the 2 lines is just the same, it will never be different. So for example, if I have got this line here, the make that, okay, if we are going to be told that this line AD is parallel to line maybe KF, what we know is that if the 2 lines are parallel, it means the distance in between the 2 lines right here, from here up that, this distance here in the between the 2 lines is always the same. such that if this line is extended toward this direction and this line is extended toward that direction, these two lines will never meet. That's it about the normal definition of the parallel lines. Right. But now, if we happen that, say, these lines can at one moment in time going to meet after extension, then those lines are not what? Parallel. Now, here about the discussion on the Cartesian plane, where we are looking about the issue of the line. How do we now determine that the lines which are drawn that are of the same distance in between, that is to say they are parallel? Right. So here, to cut the story short, since I'm alone here and you are somewhere invisible, I will just be in the position just to give you somewhere some guidelines, but I will there at least to ask you to say how best can you determine the lines that are parallel behind the issues which I've just mentioned here, that the line in the normal circumstances which are parallel have got the same distance in between. Right, so now the main clue that you can use to determine that lines are parallel in the normal circumstances based on what we're discussing here, you can use the issue about the measure of a slope. Measure of the slope, what we define it as what? Gradient. Right. Measure of the slope with respect to the horizontal axis. If the measure of the slope, that's the gradient, is the same, that tells us something that these lines have the same slope and they're heading toward the same what? Direction. There's no way that if you have lines here which are having the same gradient or the same slope, we go towards different what? Directions. These lines will always go towards the same what? Direction. So we expect that if line AD is parallel to line KF, then gradient of AD must be equal to or exactly the same as gradient of what? KF. So AD and KF, if these lines are deduced to be parallel, then these two lines must have the same what? Gradient. Slope must be the same. Right, so that is the main clue that you can use to determine that lines are parallel. Wake up the gradient for one line, wake up the gradient for the other. If they're different, it means those lines are not what? Parallel as such. Right, so you can do some kind of practical activities where you are. Try to have any two pairs of lines. Draw the graphs of which. Right, you'll find that the graph that you're going to draw there will be straight lines, and try to calculate the gradients, then be able to recognize that these two lines have got the same gradient, then they must be what? Parallel as such. Alright, now let's get to the next category of discussion, where we need at least to determine the following equation if they are what? Parallel. If I'm talking about this equation, it's more like I'm talking about the line, because the line has to go along with the equation. No line shall be drawn without an equation. So it's more that every line that we'll be talking about here must have one equation within it. So sometimes I'll just be writing an equation, but I'll be describing it as a line. Sometimes I'll just draw a line, I'll define that one as an equation, because these two are just like one. Right, so what we need to do here in the first circumstance here, let us discuss the following example before we go into the other category of our discussion. Right, lines, same gradient, it means the lines are parallel. What if now we are given the following pairs of lines? Are the following lines parallel to each other? Right, let us have this problem, and let's determine if the following lines are parallel. Right, so the example goes like this. Determine whether the following lines are parallel or not. Right, the first pair has got a line y is equal to 2x minus 7 and 3y is equal to 6x plus 2. Right. The second line, the second category of lines here is another pair where we have 5y plus 3x plus 1 is 0, and here I've got 10y plus that is 6x minus 1 is 0. Right. Lines are parallel if they have got the same gradient. Now, in the first example, y is equal to 2x minus 7, first line, versus another line whose equation is 3y minus 6, is equal to 6x plus 2. These two lines parallel. Right. So what we're going to do here, the direction is issue about the gradient. So you talk of A, you're going to calculate the gradient of the first line, use of gradient, y is equal to x minus 7. Right. If I'm to use that talk of the general equation of the straight line, defined as y is equal to mx plus c, where y is the subject, then that equation should be able to show us the gradient. So based on our discussion, we said the gradient usually is a coefficient of what? X variable in that equation. So like in this case, by the format y is equal to mx plus c, and our m is represented as a gradient, you find that the story here is just normal. The equation given here already in the form of this kind. So here we have got y is equal to 2x minus 7, while the form say y is equal to mx plus c, where m the gradient, the definite in this case, our gradient is 2. Right. So it means in the first pair of the lines, the gradient of the first line here is equal to what? A 2. That is the measure of the slope, if we are to draw the line for that equation. Secondly, let us find the gradient of the other line for this pair. So this other line, we are given 3y is equal to 6x plus 2. Right. If we were to match this equation with the general form, you'd find that this equation doesn't have y as a subject. So what we're going to do here, we need to make y as the subject of the formula, right, or the subject of the equation. So in attempt to do that, we would need to eliminate the 3 here and make y having the coefficient as 1. So to do that, we have to divide by 3 throughout. Here divide by 3, here again divide by 3. So we have got 3 here, 1, 3 here, 1, and we have got the y, the subject, then 3 gets there to x plus 2 over 3. Right, so we'll be able to deduce again in here, make that we are having the gradient recognized by the coefficient of x, then definitely here the gradient is also 2. So you can see a gradient is 2, the gradient is 2. Then we're really going to conclude that the two lines are what? Parallel. Right, so line y is equal to 2x minus 7, and line 3y minus 6, 3y is equal to 6x plus 2. These two lines are what? Are parallel. Right, that is their status. Let us finish up with example B. Are those two lines again parallel as it is for the first pair? Right. So please learn us, this topic is not all that difficult and doesn't have a lot of things within it. Just straightforward. It's just issue about the study of the line. Right. So for the second pair, the first equation is defined by 5y plus 3x plus 1 is 0. We still have to make y the subject of the formula. So what we're going to do here, it means we have to transfer these other terms which does not have a y variable to the other side of the equation. So that this side here, we should remain with a term with the variable y alone in attempt to make it as a subject. So I'll have 5y is equal to, this 3x comes as negative 3x, then the negative 1. So once we have done that, let's divide each term by coefficient of y, which is a 5. It will go like this, divide by 5, divide by 5, divided by 5. So you have like that one, 5.5 is 1, and I've got my y here equal to negative 3 over 5, x minus 1 over 5. So here, which means our gradient is equal to coefficient of x, and in this case, it is negative 3 over 5. Yes. Let us also do the same with the other equation. What is the gradient of 10y plus 6x minus 1 is equal to 0? So here we are. We're also going to transfer all terms which does not have y variables to the other side of the equation. So here we have got 10y will remain like that, equal to 6x should go to the right hand side. 6x, the negative 1 comes the positive 1. Then I divide both sides by 10, divide by 10, divide by 10, divide by 10. So 10 into 10 is 1. 1 times y, I get a y. And here you can see the common, I can try to check for the common factor. For 6 and 10, you find that it's a 2. So 2 gets into negative 6, negative 3, and 2 gets into 10 as a 5. So 5x plus 1/10. That's what we have. So if we are to come up with or determine the gradient of this line, we're going to deduce it as a negative 3/5. So here gradient is negative 3/5. Here again the gradient is negative 3/5. So in this case it means the two lines are what? Are parallel. Right. So that it is about the study about the parallel lines here. The first thing, determining or getting to know that lines are parallel. How do we know that lines are parallel? So everything is by what we've just done in the example. Right, the last part now in the same issue about the parallel lines is an issue now of coming up with an equation. Apart from knowing how to identify that lines are parallel, the next thing that you students need to know is to calculate the equation of the line that is parallel to the other one. So let us now have this example. Right. Fine. In this example, we are given two lines with the following characteristics. They say we have a line, maybe let me give you this other example. I think this one is the best one. Okay, let me just have this one. Example 2, issue about the equation now of the parallel lines. We are told that say there's a line, arrow. This one we're told that is parallel to a line whose equation is y is equal to what? 4x minus 7, and passes through a point which is 1 comma negative 2, right? So they're asking us to find the equation of line what? Arrow, right? So that's it. We are given two lines and we are told that one line is parallel to the other one. This line's gradient is known, its equation is known. What is the equation of the other line parallel to it? Right. So in the circumstance here, it's like I have this line and I have another line. One line is arrow, another line is defined by an equation which is y is equal to 4x minus 7. Two lines. So you can take it just like arrow 1 and arrow 2. Right. So they say the two lines are parallel. It means they're heading towards the same direction. So once we are told about that, it means we have to bear in mind that these lines, as much as they're parallel, it means they've got the same what? Gradient. So our task here is simply to calculate the equation of this other line. What is the equation of the line? Arrow. While the first equation, the equation is y is equal to 4x minus 7. Right. So you as a student, I don't think you can hesitate in this case. What you could do is just to consider it work by any one of the two methods that we have discussed on how to find the equation of the line. The two methods we have discussed in the past. Use the link to at least revise the previous videos and you'll be able to notice the two methods. So I'll use one of them. This is by use of the general formula. Right, so here with the general form, what I'll have is first of all to indicate that formula down like this, to say equation of a line is defined by y is equal to mx plus c, where m is the gradient and c is the y-intercept. So what we need to do here, I simply just have to find the value of m and find the value of a c. Once I have them, then I just have to substitute for them. Right, so it's like now, how do you calculate the value of m? For this line here, we are targeting the line L. Right, we don't have information about L, enough information. What we are told is only that this line is passing through the point. We can have this one as the point, let's say 1, -2. That's the only information we have. But since we are connected to this other line, we are told that this line is parallel to this one. So we may be able to deduce in that case that, say, if we have got two lines are parallel, if I need to work out for the gradient, then the gradient for the two lines must be the same. So what does this mean here? It means the gradient of this line again is also what? A 4, coefficient of what? X. But now, this is a different line. Here, this line has got y-intercept as -7. But the line, this case, is y-intercept is not known. So we need also to work out the value of the y-intercept, exactly where does this line cuts the the y-axis, y-intercept. So by what we have already discussed earlier, if I need to work out the value of what? C, I can use this very same point and the given gradient to come up with the value of C. How? This is the nature of the equation of a straight line. The y can be substituted for the y coordinate, which is -2. So write here -2 is equal to, for m, I'll write it 4 multiplied by x, in this case is 1 times 1 plus c. So what I have here is -2 is equal to 4 plus c. Like terms together, I'll take my 4 come to the left hand side and I'll have -2, -4, which gives me what? That gives me a c. So if there I'm to simplify what I have there, I'll be able to come up with the value of c as the -6 is equal to c. So c has been found. Then at the end, what should I do? I just conclude as to say equation, in this case, is y is equal to mx plus c. The y comes in, m is a 4 multiplied by x, for the c is -6, here I write -6. So a line y is equal to -4x minus 6 is the line that is parallel to y is equal to 4x minus 7.